Okay, here's a wild thought for you. What if I told you that the physics behind the most destructive, most extreme object in the entire universe has a surprising connection to that device you carry around in your pocket? Today, we're going to explore this really powerful analogy, the black hole in your phone.
Yeah, I know it sounds a little out there, right? But stick with me. The answer is this fascinating way of thinking about compression, about physical limits, and even about our own attention. To really get it, though, we have to start on the cosmic side of the equation.
So to understand this, we have to think on a scale that it almost breaks your brain. We're talking about the final, violent moments in the life of a truly massive star, as it just starts to give way and collapse under its own impossible weight.
So what is a black hole, really? It's basically the end of the line for gravitational collapse. It's what happens when you push matter past its absolute breaking limit, when it's crushed into oblivion by its own incredible mass.
And this right here, this is the part that's so hard to wrap your head around. Just try to imagine the mass of our sun, or, many suns, squeezed into a space so tiny it defies all logic. That is the essence of a black hole. Extreme, unimaginable density. But what truly makes a black hole is something called the event horizon. Now, it's not a physical surface you could touch. It's a boundary in space-time itself. And once you cross it, that's it. There's no coming back. It is the ultimate one-way trip. Okay, so hold that thought of cosmic collapse, because we're about to jump into a completely different world.
And here, the feeling is the total opposite. It's not this slow, heavy collapse. No, it's a rapid, brilliant explosion of progress. For the last century or so, we've been on this relentless mission to make everything smaller, faster, and just infinitely more powerful.
I mean, just look at this comparison. It's staggering, isn't it? The kind of power that once needed its own dedicated, air-conditioned room now just lives in our pocket. And it's thousands upon thousands of times more powerful. This is a whole different kind of compression.
And we actually have a name for this: functional compression. See, it's not about gravity. It's all about human ingenuity. It's the art of cramming more and more function, more memory, more processing power, more capability into less and less physical space.
So how did we pull this incredible shrinking act off? Well, it was a whole bunch of innovations working together. We got ridiculously good at semiconductor manufacturing, basically printing circuits at a microscopic scale. We mastered transistor scaling, which is how we kept doubling processing power every couple of years. We had breakthroughs in materials science, and our understanding of information theory taught us how to encode data way more efficiently. Every single step let us pack more into less.
Okay, so now we have these two really powerful forces of compression, right? The cosmic collapse creating black holes and the functional compression creating our phones. So let's see where these two big ideas collide. And this is where the analogy gets really interesting. On the one hand, yeah, both processes are concentrating something, either mass or function, into a smaller and smaller space. And, believe it or not, both are approaching the fundamental physical limits of our universe. But the differences, well, they're huge. A black hole is a natural, kind of chaotic result of gravity. A smartphone is the product of deliberate, meticulous human design. One is governed by general relativity, the other by the precision of engineering.
So let's bring this analogy home now to something a lot more personal. Because this isn't just about hardware, is it? It's about us. The more capability we manage to compress into these little devices, the more of our own lives they seem to pull in with them. This quote from the source material just captures it perfectly. These devices, these tiny little hubs of compressed function, they have their own kind of gravitational pull, a pull on our time, on our focus, and on our social lives. So, it's a fair question to ask ourselves, isn't it? As all of our communication, our entertainment, our work, and our knowledge gets compressed into this one small object, does it create its own kind of event horizon for our attention? A point from which it's really, really difficult to escape.
This brings us to the future, because both of these stories of compression, the cosmic one and the technological one, are ultimately stories about hitting walls, about reaching the fundamental limits of the physical world as we know it.
The reality is we can't just shrink transistors forever. As we get down to the scale of just a few atoms, the rules of physics get weird. The strange rules of quantum mechanics take over. Electrons can literally tunnel through barriers they shouldn't be able to cross, which causes all sorts of problems. In a way, our engineering is approaching its own kind of event horizon.
And this brings us right back to the core distinction. While the analogy is really powerful, we have to remember these are two fundamentally different domains. One is the physics of the very, very large, and the other is the physics of the very, very small. It's like they're playing by two different rulebooks for two different universes of compression.
Which leaves us with a fascinating final question, doesn't it? If we're reaching the absolute limits of compressing hardware, where does that relentless human drive to compress and compact things go next? Is the future about compressing software, data, maybe even time itself? Now that is the next frontier.